Hello, good evening, everyone. And welcome to this session on data science. All right. So we started working on with data frames, right? Especially we started loading the data from Google Drive, and we started doing some kind of analysis on the data. And probably, as we have discussed, data frame is one of the most heavily used, especially when you are working with an Excel file related data or a CSV file related data. Yeah. I'm coming to those functions. Possibly. Yeah. So we have just loaded the data. Possibly, you can take what you should try doing is you should download any dummy data from Kaggle. Yesterday, we looked at that website as well, right? You create an account, you download some data, and possibly start exploring the data the same way we are trying to do in the class, right? Possibly a lot of insights will come. The same code, change the data, possibly the insights may change quite drastically, right? So here you could see we have loaded the data, and once we have loaded, we have looked at the info of the data. We have used our first function called info. Info as a function is giving for every column what were the number of non-null values, non-missing values. What were the count of non-missing values? And what is the data type of each of them? So if required, we might very well convert also, right? We might, if we are finding that the data type of one of the values, like someone was mentioning yesterday, how come age can be an object, age can be a number? So it can be either integer 64 or float 64. How can it could be an object? Now, we will have to see what is the data. We will have to observe the data. And based on that, we can very well say whether the age should be a number or it can continue as a string, right? So for that, you can very well look at the head and tail functions, which actually give you the initial few values and the last few values. Now, see, when the data is pretty large, either in terms of rows or in terms of columns, especially you look at in terms of columns, what happens is the default behavior is it will show only some 15 or 20 columns. If there are more than the 20 columns, I don't know what is the exact number, but if there are more than that specified number of columns in any data, it will put dot dot dot. So it might show initial 10 columns, put a dot dot dot, and it will show the last 10 columns. And in the middle, whatever the columns that are there, they would go under dot dot dot. Similarly, it can happen with the rows as well. So sometimes what can very well happen is, if at all you really want all the columns to be displayed because we want to observe the data, right? Then you should set this max display dot max columns. Either you set it to a very large number, right? Or you set it to none. So if you are setting it to none, it will typically set it to no limit, right? So possibly you are setting max columns to none, and similarly display width also, because the overall width also should be like a very so it should show each and every column with a very clear cut heading. So the width also should be set to as large as possible. And you are saying head. So you take the name of your data frame and you say head. So the head of a data frame is typically by default it extracts 5. By default it extracts the top 5 rows in the data. But if you really want to change, I want top 10 rows or something, you can change the number in the bracket. Similarly, the tail will give you the last 5, right? So it will give you the last 5. And possibly if you want some random 5, because the intention of doing this exercise, right? If you are looking for some random 5, you use sample. So you see randomly it has given some 44,000, 4,446, 465th row, 31,884th row, and so on. So randomly it will give some rows. The intention is to see randomly you check the data rather than checking all the data. Possibly if I do this 2-3 times, a different random list comes out in every iteration, and possibly I'll quickly check if all the values as per my expectations or something is deviating from the expectation. So that is what we do, random check of the data. Initial check is, okay, has it loaded from the first row properly? Has it loaded up to the last row properly from the tail? And in the middle also are the values. What are the kind of values that are there under each of the column? So some kind of a check like that can very well be done. Then, of course, index is something which we have been discussing, right? Possibly we can use the location. We have used the location and location as a function. We have used in the series case. So we will be using it in the data frame also, right? Index is typically for this default. If you are saying index, it's just a kind of auto numbering that is happening, starting from 0, stopping at 1,48,670 in steps of 1. Then we can do the subsetting of them by using the LOC and ILOC. Just wait for a few minutes. We will handle that. Now, unique is one more thing, right? Unique is one more important variable which will tell me what are the unique values under each of the column. What are the unique values under each of the columns? So you can do it with a single series object, which means you take only one column of the data, right? You take only one column of the data and you say dot unique. You will get the unique values of that particular column. On the other hand, you can very well do it with a data frame also. So you can simply say dot, you can wait for the list of functions that you can use. Okay, so it is unstack is only there, unique is not there, right? Possibly you can very well say n unique, number of unique values. You can't get the unique values for each one of them. You can get the unique values only for a single series, but you can get number of unique values of each. So you could see that ID is having 1,48,000 unique values. Year is having only one unique value, right? So it is saying now year is having only one unique value. Okay. Year is having only one unique value. Loan limit is having two unique values, and so on. So we could see that in some cases, the number of, we'll see, I think unique values we'll see for a column. I think I already have this n unique. Let me just delete it here. So you can very well get the credit score values. What are all the unique values for credit score? So I'll simply take this. I'll simply take this and possibly look at the name for credit score. Credit underscore score. So I look at the unique values for credit underscore score. It looks like these are all the unique values that are there. So for each of the columns, you can vary. So it's the unique will work at a series level. The unique does not work at a data frame level. It works at a series level. So unique is the unique values of that particular column. So as we said, 758, 552, 834, they are all the unique values for the column called credit score. But n unique is number of unique values, 1, 2, 3, 4, 5, 6, 7, 8. So it is counting the number of unique values in that column. So n unique, so it can be applied to a series or it can also be applied to a data frame as well. Now, this is a very, very important learning. Possibly the year is only one value, one unique value is there. Now, what we say is any column that has only one unique value, right? Any column that has only one unique value possibly is not adding any value in the model. Because there is no difference in the values at all. That column will not add any information to your model. And on the other side, it can increase the error part of it also. So because there is no variability, the assignment of the coefficient to that particular variable will become very difficult. So those kind of variables are called zero variance variables. In our terminology in data science, we call them as zero variance variables because there is no variability at all in the data. And they have to be dropped as a part of the pre-processing exercise. One of the pre-processing steps is the year as a column has to be dropped, right? Then the all others, possibly 2 values, 4 values, 2 values. So all are more than one. Terms, there are 26 different terms. Loan amounts, there are only 211 different loan amounts. Rates of interest, 131 different values are there. I don't see any other zero variance column. So possibly based on that zero variance criteria, if I am doing a kind of a data cleanup, better I should remove this column called year from my model. Then ID is a column that is just there dummy, just an identifier. Possibly it could be a number. I could have given the names also as IDs. So that ID does not have any role in the modeling. So possibly I can even delete that column as well. So possibly it is looking like I can drop these two columns at this moment. I can only from this level of computation, I can simply say that possibly I can drop these two columns from the data. One is an ID because everything is variable here. And possibly it does not add value. It's just a kind of a unique identifier. It does not add value. Whereas here, it's a zero variance variable. So even these two things do not add any value in the model. Right? They can very well be deleted. All right. So when we are building a model, machine learning or any statistical model, it's better that we remove those two columns from the data. Then the next important analysis that you would do is value counts. Value underscore counts as a function is primarily, you can use it for any column, right? Or you can use it at a data frame level, or you can use it at a single series level also, right? So you can very well say how many values of, so how many unique values are there, and for each unique value, what is the total count? So basically, if I am doing it for status, then it means that I have 1,12,000 zeros and 36,639 ones are there in my data. So that is what is typically being mentioned by the status column, right? And you can very well put this in a loop for the entire data frame. If you really want this, you can put it in a loop. Probably I'll show you slightly later. So for every column, you can take this kind of a input data, because there is one more important reason for doing this, right? Any group, any category which has a very low value count. When I'm saying very low value count, probably in terms of count, the values are less than 20 or something, 20 or 30. Here we have 36,000 and 1,12,000, but there could be some categories where the value count, where the count of that particular category could be very, very low, 20 or 30. Now, it would be either better to remove that category from the model. So when you are removing any data from, and when you are removing or deleting any data, it means that you are putting a scope on the model, right? Possibly if, let's say, I had the third status called can't say, right? Or unavailable. And let's say there are only 15 such kind of observations where that status was being seen. It would be better to remove that status from the model, because with just 15 observations, whether it is the machine learning or the statistical model, probably the prediction accuracy may not be that good. So any category, whether it is a dependent variable, whether it's a target variable or a feature variable, it doesn't matter. But if the frequency of that is very, very low, it's better omitting that variable from the model, right? So that category from the model. So delete those observations for that particular category, or merge it with some other category. Sometimes you may always merge all of them and say others or something like that, right? So now we will get into some kind of data man. So this is the reason why we will look at typically the unique observations, the value counts. These are some of the functions that really help us in getting a lot of initial insights into the data. Then the data manipulation, that's the most comfortable thing that you can do with pandas. You can work with almost every type of data, right? So the first thing that I'm talking about is selection. So the indexing, slicing, I think these are some of the most important aspects when you are saying I'm working with data frames. So I want to select some particular rows or columns in the data, right? I want to work. So basically you can use, it's just like a list that you have worked with in Python, right? And probably we are having a series object. The series object is much more faster because it has some indexing mechanism in it. We have already discussed that. The indexing mechanism of the series object of Python actually makes the data extraction process much more faster compared to the traditional list of Python, right? So when you start working with only one row or one column of data, then that is what we are calling as series. We have already discussed this as well. And if you are talking about more rows and more columns, then it becomes a data frame. So a lot of functions, they can be commonly utilized between the data frame and a series. So let's say I'm getting the column value for the status. And I want only the status column. So then probably simply put a square bracket and extract the column name. And if you put it as a column, so because it's only one column, it becomes a series object. Right? If there are multiple columns, it becomes a data frame. If it is a single column, it becomes a series. And you can write the type. Type is a series, and head. You can still get the head and tail for a series also, but you cannot get the head and tail for NumPy array. Right? On a NumPy, if you say head, it will give you an error. So you have to be very clear what is the data type, so that you can very well use the appropriate functions on the data type. Right? So possibly you see here, then I'm also interested in, let's say, getting two or more columns. So this is the one where I have got a single column. And now I am talking about getting two or more columns. Let's say the status, default status, and the credit score. So I want to get two columns. Then you see you are getting one extra square bracket here. So if you want more columns, you put all the column names in one square bracket and you enclose all of them in one square bracket. So if you are running this, possibly you are getting status and credit score. So only two columns are getting extracted. And now let's say you want to get, so you can say the first 25 columns of the data frame. So you can very well say head. Right? You can very well say head, and it will, in the head, you can give 25. So it will give the first 25 values. The other way of extracting is you put a start, stop, colon, start, colon, stop, colon, step. So even that is a way of slicing. So here I want, so start, I have not mentioned, which means it is beginning, it is from the beginning. Stop 25, which means it will go until the index number 24. And I have not given an is to step, which means it will increment by a default step of 1. So it has printed the values from 0 to 24 index. So all the columns have been printed because we have already set the maximum display columns to none, which means infinite. So sometimes I want to get alternating rows, right? And only the two columns called credit score and gender. So now you see here, first three alternating rows. So I'm starting with, so if you see here, I'm starting with blank. I'm going up to 6. So which means 0 to 4, because I'm saying increment of 2. So we are starting from 0, right? Possibly we are going up to 6 means up to 5. 6 will not be counted. And an increment of 2. So we will get the rows called 0 to 4 rows. And the columns wise, again, if you look at here, so first thing you are taking this. So which means your overall data frame. So if you are writing only up to this, then you will get the first three, 0th row, second row, and fourth row, all columns. Then you are putting another square bracket saying you require only these two columns, right? So in that case, it will print only credit score and gender in result 1. The result 2, there's a second way of writing the same. First, you shortlist on the columns. So here you have first shortlisted on the rows, and then you took the shortlisting on the columns. Here you are first shortlisting on the columns, and then you shortlist on the rows. Either way you do, your result is the same, but you need to be very clear on, but you are specifically mentioning how do you write this particular piece, right? So that is one more important aspect. So because after that I have simply compared result 1 and result 2 to say that all of them are exactly the same. So when you are seeing is result 1 equal to result 2, we are getting the result saying they are true in all the cases. So you could very well use either of the mechanism, right? So possibly you can very well first access the rows, subset on the rows, and then you subset on the columns, or you can very well subset on the columns and then you subset on the rows. All right. Why in column? As I told, if there are multiple columns that you are accessing, then you need a double square bracket. Can we get first 25? Okay, I'll first finish off Nayan's question. Double square brackets everywhere. Even if we are accessing multiple columns, we require double square bracket. If you are accessing only one column, you don't need to mention this because you are giving it as a list of columns. So if it is a single column, you can just give it as a column value. But if you are talking about multiple columns, you will have to give it as a list of columns. So list of columns have to be in a square bracket. Oh my God, you got the point. Can we get first 25 columns from the data? Acha, you want first 25 columns from the data? Yes, you can get. So this is, you are getting the first 25 columns from the data for only these rows. Or possibly it is all the columns are coming. Yeah, we can get, I think we'll have to look at possibly we can Google it. So I think on Googling you can get all the scenarios, right? Possibly all these are very much possible. Yeah, iLog, not log, sorry. Well, I'll come to the iLog. So this will give you the, so you're getting all the rows, or possibly if you want to give the same logic of 0 is to 6 is to 2, then you will get only the first 3 rows and you will get only 25 columns. It will come only up to income. So I'll talk about this iLog format just in a while from now, right? iLocation, location, and iLocation. So iLocation is more like a row and row comma column kind of a format. Which rows do you want? Which columns do you want? And even here, if you want to get alternate column, not every column, then possibly you can do this also. So ID, so the second column will be missed, loan limit, then fourth column will be omitted. So like that, you can bring only some specified columns also in a kind of a loop. Yeah, I think our friend has already given. So I mean, you can try different ways. So the extracting of the data possibly is one side of the story. I mean, once you know how to use pandas, you can take the help and you can very well get your work done. So the basics have to be very clear. Once the basics are clear, I think you can very well work your way out to extract things. Okay. So now the next thing that we are talking about is the usage of LOC and ILOC. This is what I think is one of the most important, or I mean, all are important, but probably if you are working out with extractions of the data, etc., these are very important aspects. So you are trying to give your queries based on the rows and the columns, right? So when you are using LOC, which is a location, so indexer for selection by label. So you are typically, you are getting into a label location based indexer and you are only selecting by a label. So it will return the end index as well. Whatever you are giving in the LOC, even the last value also would be considered. Just let's use this in an example. Whereas in ILOC, you are going with an integer location. Here it's a label location. So in an LOC, you are going with a label location. So you will give your column number, row number, index number and the column number, column name. Whereas if you are using ILOC, you are using a purely integer location. So just like in a NumPy, the row number and the column numbers. So those are the ones that go as an input into your ILOC. So you can do a selection based on position. So if you say first 25 or alternating 25, in those cases, it is like you are shortlisting by position. Whereas if you are saying the loan amount column, then you are going by a label based selection. So you could clearly see here if you are using LOC. First of all, okay, if I am looking for the two columns, so I am shortlisting based on the columns. Then I am saying, so I have got 2 columns of data. Then I'm simply going with which rows do I require. And for those rows, I'm simply using the start, stop, increment. So from the 0th row, go up to the 5th row in increments of 2. So you'll get 0th. So earlier we have used without ilog. We have simply done a kind of subsetting. And here we can very well go with a kind of ilog mechanism as well. So this is one more way of extracting. So basically you can use multiple ways of extracting. So you just need to, so in pandas, any function that you are using, just be aware of some of these functions. Then the next thing that we are talking about is filtering. So basically in your input data, you apply some kind of a filtering mechanism. Positive values, only males, only females, right? Or possibly people having a credit score more than 500. So like that, you can put some kind of a filter, right? And most of the times in some form or the other, you would be doing some kind of filtration in your work. So all of them that are having a zeros, all of them that are having a null values. So you can very well put many such kind of a filters to extract out the data, right? So possibly we are seeing, so I want to find out all the instances where the gender is mentioned as sex not available. I want to look at how many are there, or I want to look at the values of that. So what is that I can do? First of all, try to understand, right? What are the unique values for the gender? So it says, okay, sex not available, male, joint. So here male is, I mean, joint is like, it's a joint account that we are talking of. So the loan account holder is a joint account. So male, joint, and female. And somewhere the gender was not mentioned. So these are the 4 unique values that were mentioned in the gender category. So I want a way to filter out the records. I want a way to filter out. Basically, I may want to ignore those values, right? I may want to ignore those values. So I'll create a filter. So as I told you, if you remember, any category that is having lesser than 20, 25, 30 observation, it's better to remove that category from the data, because it does not add much of a value to the overall analysis. I mean, it's not that a reliable kind of an estimate or reliable kind of coefficient that we will get for that particular variable or for that particular category. So it's better to remove that category from the model. So possibly here, if the sex not available is coming only in 10 observations or something, then I would better feel that it should be removed from the model. So that's where I'm setting a gender filter, where I'm saying I'm just taking the gender column. So if it is 1 column, I don't need to put double bracket. So I'm taking the gender column, and so I'm converting that gender column into a structure. So I'm taking the string part of it, not structure, sorry, the string part of it. And I'm saying whether the string contains sex not available. So I have looked at I've used the exact wording, including the tense. Otherwise, I may have to convert it into a lower or a upper or something like that. So this one, it will simply give me true or false. So for every observation, it will give me true or false. If it contains sex not available, it will give a true. If it does not contain, it will give a false. It's a Boolean, right? So that Boolean, I'm taking it as an input into my data frame. So overall, if you do this, you will just get these rows. So 37,659 rows, they have sex not available. So it's not a small number. Possibly the gender of the person is not available. So sometimes we may say, oh, if though it's not NA here, but still it is being written as sex not available. So there are two things. One, you can delete this observation because saying that gender value is not available. Or on the other side, you may say possibly people who have not mentioned their gender, has it something to do with the default? Can this be I mean, people are intentionally not mentioning their gender, and are these people contributing more to default? If you start thinking in that way, then possibly sex not available could be an additional important variable as well, and you may not want to delete them. So you have to think through the problem a little bit more. Now, the another kind of subsetting that you can do is by giving multiple rules, right? You see here, I want those customers who have a credit score above 800 and the loan to value ratio is above 90. Do I have any such kind of customers? How many such kind of customers are existing for me? Right? So possibly I may want to see how many such kind of people are there. Right? So what is that I'm saying? My first rule is default DF credit score greater than 800 and default DF LTV column greater than 90. So I have put two rules joined by an and. So if this part is true and this part is true, then only the total will be true. So whichever are the rows that are having a true, I will put default DF. I will extract those rows. So this problem will say, oh, I have somewhere. Why is the LTV creating a problem? Default DF credit score first. Let me check by one value. Okay, this is showing me correctly. Oh, I think we have renamed it as loan to value, not LTV. So this is loan to value greater than 90. So you see there are only 6,200 rows, right? Because we did not set maximum rows is none, display max rows is none, it is showing only first 5 values dot 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 and again the last 5 values, right? So in our logic, whenever we are using it in logic, we will always put this ampersand only whenever we are doing the comparisons, we'll always put ampersand here, and possibly a kind of a pipe for or, right? For this pipe symbol, we'll put for or. So when we did an and, we got some 6,200 rows. And when we are going for or, we are getting 55,000 rows. Okay. Yeah, I think we have resolved this. So fine. So typically, this is a kind of a cheat sheet for you. So if you are saying DF or data frame, you put some column name, only one single column. So you are getting a single column. So in that case, you just put a simple, this is a kind of a ready reference for you. So it's a simple one single label. Then if you are putting, if you want two or more columns, you put all of them under one more square bracket because you are getting a list of columns. List of columns means you put one more square bracket. Then you can put start, end, and step. Start, end, and step. Then you can very well get only those rows. So possibly you can get alternate rows, every third row, every fourth row, something like that. If one is true and the other is false, your and will be false. So that row will not be extracted. Only if in case of and, both conditions or any number of conditions that you give, all the conditions need to be true, then only the and will be true. In case of or, any one condition need to be true, then the whole data will be true. Okay. Then this is a third way. This is the filtering way. Boolean array or a Boolean DF, right? We have already looked at it. We have done a filter, and based on a filter, we get true or false. You pass that true or false as an input to your data frame, you will get only those rows, right? So that's a fourth way of extracting the data. Then in a location, you specify the rows and the columns. You specify the rows that you want, you specify the columns that you want. You can use the LOC. And you can well use ILOC by giving the numbers of the rows and numbers of the columns that you want. The labels of the rows and labels of the columns, then you can use LOC. The numbers of the rows and the numbers of the columns, you can use ILOC. So this is the kind of accessing the subsetting of the data. Right? So this is one more important thing that you are supposed to be comfortable with. Then you can talk about the series related operations. Right? It could be data frame related operations or series related operations. What you could very well see here, if you are just like in NumPy also we did this, you simply do some kind of an arithmetic to an entire series. So this is an entire series credit score. So let's say I want to increase all the credit scores by 10. So you can just take the column and you just add whatever the value. So add, subtract, multiply, delete. So if you are multiplying, so this is like addition by a scalar, one single value. Addition by a scalar will always apply it to all the values. This is what is called as a principle of broadcasting, right? It will apply whatever. Now you say I double the loan amount for everyone. You simply do a multiplication by 2. Take the whole series, do a multiplication by 2. All the loan amounts will get multiplied. Now, if you want to divide one value by the other, this is what we call as feature engineering. You create new features or possibly feature creation. As a part of the feature engineering, there are various steps. So you can call this as a feature creation step. So in this feature creation step, let's say you want to divide the loan amount by the property value, and you want to say that this is the new LTV calculation for me, right? Either you want to add it to the same table, or you want to calculate it separately. Now here I did not add it to the same table. I have calculated it separately, saying loan amount divided by the property value. So possibly wherever the property value was blank or something, this value came out to be and not a number, right? But in the earlier case, when we have just looked at the LTVs of each of the columns, we did not see too many blank values in the LTV. LTV, yeah, there are some blank values, but property value, there property value also we have equal number of blank values, so it looks fine. So because the denominator is having some blanks, LTV was also having the same as blank or missing value. So possibly we may have to see that those records, what is the kind of value addition that they are going to bring to the overall. Now we will get into some other list of functions, right? Possibly before that, let me just look at. Yeah, please give one example of LOC. We have discussed about it as well. So let's say I will create some rows, right? I say the rows are indexed with, right? So possibly I'll put it like 0, 10, 25, 50. These are the rows, right? So these are the index because we did not have any names. So let's say I say column select is equal to, I put some columns. What are the columns? Let's say I say ID, gender, I'm just taking some random values. Okay, let's say I want these rows and these columns. So I can very well say my df1, I'm creating a new data frame which says df.loc. I give my rows and I give my columns. So these are the rows you select and these are the columns you select. I've given the index, I've given the names of, so by labels, I've given the labels for each of them. What are the labels out here? Just let's see the label for rows. Okay, the DF has become 0 to 4. Oh, okay. DF now contains greater than 800 and greater than 90. Sorry. So possibly these numbers are not there in the DF. So default DF is what we'll take. We'll take default DF. So we will print, right? We'll print the DF1. So you could see here, we are getting the selected rows and selected columns. So that is what you can do with the LOC. Are we fine? Not required. When you are treating them separately, you don't need a double bracket. Right? Sometimes this gives a clarity. You can very well possibly you can do this. Right? Sometimes you may want to avoid multiple lines of code. Then you can very well do this exercise as well. Even this would possibly, I'll write it as a separate line. So what you can do, all these rows, you have put them as a kind of list. All the columns, you have put them as a list. So you can even do this exercise also, and you can do the print. So you can very well avoid these two lines in case you have written it like this. So it's all your comfort, right? Sometimes you can give more clarity by adding separate lines. Sometimes you may want to save the space by writing both of them in a single thing. So this is one. Then now I am getting into a function called a few important functions, which are more like your aggregation functions, right? See, many a times you can write your own function and apply that function to a specific column, to a specific series, right? So basically it's like you create some function. So I'm saying, I'm just possibly say square, right? Or possibly we'll say square cube of value. And I'll say value square plus value cube. I'm just saying I require the sum of square and the cube, something. And possibly I would also put np dot square root on the top of it. I don't know what I'm doing, but something I am keeping. Now, this is a function that I have created, right? Now what I am saying, I will apply this function to this amount, to this column called loan amount. So any function that I write or any function that is already available. So many a times with the general function that we are writing by using the def, I can apply that function to a specific column. So possibly what is going to happen here? Okay, somewhere I think the values. Okay. Possibly I can do it right this. The data types are mismatching because again the value squared and value cube are coming on a pandas object, whereas np dot is coming from a numpy object. So sometimes we can avoid those kind of discrepancies as well. Now, the next thing that we are talking of, yeah, new name will insert a new column named new name in the data frame. You are right. I think someone has asked the question. Okay, Chavi. Can we add this newly calculated variable? Yeah, I think whatever our friend Ashok has explained, I think you can take that. So you just put the name of the DF around in the square brackets, it will create a new column. Then the next thing that we are looking at, the next important function is the describe function. Describe function is primarily talking about the summary, the number of observations, the mean, the standard deviation, the minimum, the first quartile, the median, the third quartile, and the maximum. So possibly in some cases we call it as a 5-point summary, but of course here there are a few more additional things compared to the 5-point summary. So this is one more set of observations that you can think of. This is a so basically here the only disadvantage is if there are some missing values and all, it ignores them, and out of the values that are present, it does the calculation. Out of the values that are present, it does the calculation. Now, yeah, this is what I think our friend Chavi was referring to. So let's say if I want to create a new value, right? Property value new. And which means I am doing some existing calculation on the existing property value. And I am assigning it to a new property value. So property value new, we are simply saying property value times 1000. Now that new column will get added to our data. Possibly you could see the last column will be property value new. So you can add new columns to your existing data by doing this kind of, so these are all like creating new features. This is what we say feature creation. You are creating new features and adding to the same data. Then sometimes you may end up doing a renaming of the columns. I think that is what I have done here in the example, and because I have run it, that's where. So LTV is the name of a column. I want to replace it with loan to value. Or possibly there could be one more instance. So you are generally the column called status, right? Here we have used it many times, so I don't want to rename it. But the target, generally status can be named as target because that is what will be your target variable in a data science exercise, in your classification modeling exercise. So you can very well name it as a target, but right now let me still keep it as this status only because we have used it in various other contexts and possibly those all can result in error for us. So LTV will be changed to loan to value, right? So and we are saying in place equal to true means you make a permanent modification. In place equal to false is just for the sake of display you do it, but don't edit it permanently. But in case equal to false, true means you make the editing also permanent. That's one more. Now deleting. So these are all the different exercises that you can very well perform. Now I said I will delete the ID column. I will also delete the year column. Because ID column is something which does not add any value. Year column is a zero variance column and it does not add any value in the model. But here I don't want to delete because possibly I want to add, I want to edit some values of that year. so that we can think of doing some kind of plotting and all based on the daily or yearly kind of a data. So right now I don't want to drop the year. I'll just modify the data so that it can be utilized for some other use cases. So drop is, I can very well drop the columns, I can very well drop the rows. And the differentiation between the row dropping and column dropping is done by something called axis. So the statement is the data frame dot drop. The syntax is data frame dot drop. Now you can very well give the labels, right? Or you can give the index values. You can very well give the labels of the columns, or you can very well give the labels of the rows. But you specify the axis. So axis equal to 1 is like column drop. Axis equal to 0 is like row drop. So you can either drop your rows or you can drop your columns. So which means after doing all this, data frame dot drop, and after, so it's creating a new data frame. And on that, you are just taking the first 3 observations. Head of 3 means you will get the first 3 observations only. Now the data column, ID column is typically dropped. Your values are starting only from here, right? And if you say, no, I have created some additional column also here, right? Possibly I have already dropped the ID, right? So possibly it would not be, I mean, in that case, it's always better to write it in the next line. Let's say here I want to drop 2 more columns, right? Then I'll give it in double quotes, I mean, double square bracket. Let's say property value new, I just created just to showcase how to create an additional column. So I'll drop that column. And I don't know, I'll have to drop 1 more column. None of them is right. Possibly right now it's only 1, but let's say I just for the sake of dropping 1 more, I'm dropping 1 more, apply 1 more column. Probably at later point we'll correct it. So in that case, possibly now this will not be there, so you will still get the error, right? And possibly you are saying axis equal to 1. Labels equal to, right? So possibly you can still go ahead. This I will, this thing. So now those 2 columns also will get dropped, right? Possibly I'll remove this, I'll add this here itself when we are loading. All right. So when we load it again, possibly this would be ironed out. Okay. So then the next thing is sorting. I hope, I think some of you have, okay, I think there are a few questions. Yeah, if you have to write in the Excel file, I think Paras has Saurabh has already given. So if you have to write to your Excel file, you have to use, I think we'll make the final changes and we'll write to the Excel file also. So you have to say to Excel or to CSV. So we have taken the data from CSV. So let's say I want to write to CSV. So it's again the same, possibly the entire thing we can write. We'll do one thing. So as I said, I will make some modifications to the year, right? So There I can talk about writing it back to the Excel file, to the CSV file. We'll just finish off this part, and we will make some changes to the year, and we will write it back to the CSV file as well. Okay. So the first thing is sort. So you can sort based on the values. So you could see here, you can very well sort based on sort values loan amount, and you can very well give ascending equal to false. So you can, so if you look at the sort values, sort by. So the by is the first variable. And in the by, it is saying, now this is very important for you. So in the by, right? By, it is saying string. So which means it could be one value or list of strings. So it could be multiple values as well. Right? So multiple values means first you sort by the loan amount, then you sort by the loan type, something. So you can sort, you can use a multi-variable kind of a sort. Then the axis you have to specify. By default, it is axis equal to 0, which means it's a row-wise kind of a sorting. Ascending, you look at this parameter, ascending equal to true. The ascending also is a Boolean or list of Boolean. So what is happening? I can very well provide on multiple counts also. So this is one way I've just sorted it based on the loan amount in a descending order. So what you could very well see here, my loan amounts, possibly 35,76,500 is the highest loan. After that 33 lakhs, after that 30 lakhs, and so on. So that is when I have sorted it based on ascending equal to false and only loan amount. Now let's say I want to do the sorting based on multiple. Now here if you see, the loan amount was duplicated. Loan amount was coming out 30,000, 30 lakhs, 6,500. I have three of these, right? And possibly, I don't know whether the income, possibly I say, wherever there is a tie, on the loan amount, then sort it on the decreasing order of the income. So which means possibly the 43,000 one should come down, and 66,000, 50,000 one should come at the top, right? So let us see if that is the kind of an objective that I require. Then what is that I can do? I can put this loan amount in a square bracket, and along with that loan amount, I can also put whatever is that income. So which means I want it to sort based on loan amount and income. And ascending wise, the first one is false. So I'm giving a list of those. Income also I'll say false. So income also will be in the descending order, and even this one also will be in the loan amount also will be in the descending order. Now let me see, this is like a multiple variable based sorting. So sometimes you may want to sort on the data and then extract the top 3, top 5 kind of thing. So here also you see 35 lakhs is at the top, 33 lakhs is next, but now we have 30 lakhs, three elements, but now they would have sorted based on the income. Now you see the 1 lakh 14,000 income came at the top, 66,000 the next, 50,000 the next. Because we have sorted in the descending order of the income. Wherever there is a tie for the first, for the first variable, we would resolve that tie by sorting it on the second variable, either ascending or the descending. Now the same thing, possibly loan values wise, I want to know what are the counts wise, which loan amount were having the highest number of count, or any variable for that matter, right? Possibly I want to know which of them are having highest. So instead of loan amount, you can very well talk about genders, right? Which of the genders are having highest count. So possibly we can do that. Or if we are talking about which are the top 10 hottest credit scores, right? What is the common credit score that we observe? Let's say that is the problem. Then I'm simply looking at first extracting the column called credit score. So this became a series object. I take the value counts. We have already discussed value counts is the frequency of each unique value of that particular column. So once I do this value counts, then it is doing the sorting in a descending order. And whatever are the sorted, I'm just taking the top 10 values. So you see that 763 credit score, a credit score of 763 is associated with 415 customers. A credit score of 867 is associated with 413 customers, and so on. Now comes, so possibly this is one more function that you would be using quite frequently, sorting. Then the next important function that you would be using is a pivot table. So pivot table works exactly in the same way as your Excel pivot table itself, right? So possibly I'm just giving one dummy example first. So basically what happens in a pivot table, the columns of your table, right? If you have created a table with let's say 4 columns, like you have created A, B, C, D as columns, right? So in A there are some values, in B there are some values, for C there are some, for D there are some. Now in a pivot table, you will select one column, right? The simplest form of a pivot table is you will select one column as the row of a pivot table, one column as the column of a pivot table, and one column as the values of the pivot table. So it's as good as saying, right? It's as good as saying, possibly here, A is having foo and bar. So what I can very well say is, possibly I can do a kind of summarization. Possibly I can do a kind of summarization saying foo is 3 and bar is 3. This is like a simplified pivot table where I just did a pivot table of counts on the A column. Or it can very well become foo and bar, all the unique values of each column. 1, 2. Foo and 1, 1, 2. Then bar and 1, 2. Possibly it is something like this. So this is the pivot table way of representation, right? So what are we saying? If I select 2 columns, I hope all of you are comfortable with pivot tables in Excel. So if I'm selecting one column, so here I'm selecting one column as my row column. I'm selecting one column as my column column. So the row column is typically A. The column is typically B. All the unique values of each of the column will be represented as the new headers. And the count or some kind of summary could be provided internally. This is what is a typical pivot table. So as a data frame, possibly this is the values. Now what is that I say? So I'm creating a pivot table. So we can do, first of all, values. Which is the values column? So values is what summarization do you require here? So summarization could be like counting, summing, averaging, all those things. So for which column you want the summary? So possibly I have a D column, which is a numerical column. So I would like to take the summary of that numerical column D. So value is for which column you want to take the summary of the pivot table. Then we have the index column. Index is nothing but the row headers. So when I say index equal to A, my row headers will be like foo and bar, just like this. Foo and bar, because they are my row headers. Now column header is C. So the unique values of the C, which are X and Y. So you will get the two new columns as X and Y in the new pivot table. Now, what is the aggregation function that you want to use? I want to use a sum function. So once you do it, you see this is how you get bar and foo, X and Y. Now let us do something based on our data frame. Right? I want, so possibly we'll try. I want you to give me a solution. Compute the average, right? Compute the average loan amount for each gender loan type combination. Right? Compute the average loan amount for each gender loan type combination. So can you tell me how do you modify this? So we can reuse this. Now what should be the value of D here? What should I put? Possibly you may not be knowing the exact column name, but just you tell me which column I should put there. Calculate the average loan amount for each gender loan type combination. So loan amount is the value that goes in, because that is what is the aggregation that I am supposed to perform. So great. So I'll say loan amount, right? So this is like a default df dot pivot table. Then my A, what should be the index here? You take one of the columns as the index. So what was the column? Gender is capital G or small g? It's a capital G. So I'll say the gender is 1. And similarly, I would take loan type as the column. And I would simply use the aggregation function as the mean. You can use some of your own custom functions also if required. Now, if I run this, I'll get a different pivot table. You see here, gender wise, female, joint, male, sex not available. Type wise, loan type wise, we have type 1, type 2, type 3. And based on that, these are the averages that have come out. So possibly by doing some visualization, you might want to really comment on the averages, etc. Possibly you may say type 2 loans typically have a smaller loan amount compared to type 1 and type 3 loans. I mean, just by a quick look of data. So you may very well say the type 2 loans are having I mean, people are taking a slightly lower loan amount in type 2 loans. That is what we could see here. And you can very well convert the whatever the pivot that you have got, you can reset. So here, these are the indexes. You can very well reset the indexes. So if you reset the indexes, what is going to happen is these columns are going to come as separate column. If you are going to reset the index, you could see loan type is simply coming out as kind of 0, 1, 2, 3. Gender is coming out as female. So basically, this columns, it would typically continue as columns, but loan type will come out with a kind of a serial number. Then gender will simply continue, and type 1, type 2, type 3. So sometimes a pivot table, if you want to convert it into an ordinary table for a kind of a presentation, you can very well do a resetting of the index. Resetting of the index is something that is showing here. It would come back to your original column as just like an original column. So we have already looked at what is the mean loan amount by gender. We have also looked at what is the mean loan amount by gender and the loan index combination, loan type combination as well. So pivot table, you should see wherever you can utilize the pivot table, you should typically resort to the using of it. Then comes the group by. This is also possibly what I suggest is you create as many questions as possible. Any data you take, you create as many questions as possible, right? And try to solve them. And that is what will give you the comfort. Can we chain functions in aggregate function? np dot mean dot floor? No, because np dot mean is giving one value, and if you take a floor, there is nothing on that, right? Because it's not a array, it's a single value. The moment you are computing the np dot mean, it itself is a single value. So you cannot get a floor on the top of that, right? But what you what I am trying to think of in your case is once you get these four values, then on the top of them, you might want to do a np dot floor. So possibly you get this loan amount, right? And possibly I may say np dot floor of this. So I got a mean amount. So for each one, again, it is coming out as floor. So we can, what we can do is, So possibly it's just a kind of waste that you are trying to work out. Hmm. Okay, so here let's take the type first. Okay, so this is a method type. So this is not a data frame. So you will have to convert it into a data frame. Possibly it could be a slightly lengthier kind of mechanism. Otherwise, you may have to convert this into a data frame. Let me just see what is the name of the function. Okay, capital F, sorry. Okay, this is still a data frame. So now what I can very well do is, so I am getting this. So I can say loan amount, and I would typically want to apply NP dot floor, NP dot floor on this value. Okay, floor is all right. Let me just check. Possibly, so because at least in the earlier question that you have raised, I think we cannot directly apply 2 because the NP mean. So floor will give the round down value. Earlier result was correct. I just want round down value. Acha, oh, okay, round down value. Okay, I was thinking floor is giving me the minimum value of each of the columns. Okay, okay. I think I misunderstood your floor slightly. I was thinking of minimum value for the column. So yeah, I think that was true. So floor is actually a rounding down to the nearest integer, and yeah, I got your point. I think I mistook it. Yeah. Then the next thing that we are trying to look at is group by. This is another important function. Possibly you have to practice these functions more and more. Right? You will have to practice these functions, because one is pivot table, which can really help you to realign the data, create multiple sub tables from one main table. So possibly you will have to work a lot in terms of getting comfort on the pivot table. Then you could also work on group by. Group bys are also used very heavily. So we can do some kind of aggregations by doing the group by. We can do some kind of transformation, and we can do some kind of filtering. So what is happening in a group by? First we filter. We split the object. So let's say I say group by gender. So all males will be, so my data will be split like this. All males data will be like a one subtable. All females data will be like one subtable, group by gender. All joint data will be one subtable, and all sex not available data will be one subtable. So basically 4 subtables virtually. 4 virtual subtables are getting created. Then applying a function. So on each subtable, you can apply possibly some aggregation kind of a function. And I can combine all the results. So you could see here, I want to simply look at all the columns, all the numerical columns. I want to compute the mean values based on gender. So all I say is group by gender. When I say group by gender, as I said, 4 different tables, 4 different subtables are simply getting created. That is what is happening in group by. So 4 different subtables based on 4 different genders are typically getting created. And then we said the second thing that we have to do is applying a function. So I am aggregating the mean. So I am taking the mean of all the columns separately for each gender. I am taking the mean of all the columns separately for each gender. And I am combining the result. So females, possibly ID does not have any meaning, right? But now we have dropped that ID. So let me just see. I think, or I may have used a different name. So here, loan amount, the average loan amounts across the genders, the average rate of interest across the genders, the average interest rate spread across the genders, upfront charges across the genders, the term across the genders, property value across the genders, income. So these are all the numerical values. So I am simply getting the aggregation. So you can say np.mean, np.sum, any of these things can very well be taken. That's one more important function. So you can say aggregate function equal to mean. And yeah, so you can, to the output that you have got, the entire output that you have got, you have apply np.flow. Okay. I think, yeah, that is also a good way of, that's a good way, in fact. Then, possibly if I'm working with 2 different data frames, right? Possibly one of them containing my customer data and the customer information. 2 is containing the product information, and 3 is containing the transaction information. Possibly, I may want to combine these 2 tables or 3 tables into one single table by trying to, there are multiple ways that I am trying to combine. One is concatenation. So in a concatenation, I am just placing it one beside the other. No rules, nothing. I'm simply doing a concatenation. So basically I have 1 to 10 rows of data in one data frame, 1 to 10 rows of data in another data frame. I'm just putting one data frame value beside the other. That is what we are doing it as a concatenation. So either I can concatenate column wise or I can concatenate row wise. So I can do the concatenation either column wise or row wise. That is what is concatenation. The dimension should match along the axis you are concatenating. So basically, if you are concatenating across the column, you concatenate on axis equal to 1. Axis equal to 1 is like a column. So if you are concatenating column wise, then the rows of both of them should be equal. Then only you can concatenate column wise. If you are concatenating row wise, the columns of both the data frames should be the same. Then only you can concatenate row wise. So concatenation is just attaching either row wise attachment or column wise attachment. That is what is concatenation. Then merging. Merging is you are simply putting a same logic based on some variable. Based on some variable. So wherever that variable is, so possibly it's like this. Possibly I'll give a small example for all three. So your data, data frame 1 contains columns A, B, right? Possibly the values are A, B, C, B, D something. And B as a column contains B1, B2, B3, B4, B5. Then again, I have a data frame 2, which has possibly A as a column, A, C, D, E. Then I have a C column, possibly C1, C2, C4, and possibly here also I have a D column with C5. Right? So when I am doing concatenate, so it might become something like A, B, A, C, A, B, C, B, D, B1, B2, B3, B4, B5. So the data frame 1 will be as it is, and the data frame 2 will get just appended. So there is no logic, nothing, because both of them have 5 columns. 5 rows. Both of them can be concatenated. This is like column wise concatenation. Whereas the row wise concatenation cannot happen here because we have different columns that are coming up out here. Right? Whereas here the row indexes are same for both of them. So this could be column concatenated, but they cannot be row concatenated. Then if I am using the merge here, so what would happen? A, B and a C will come in. And the merging will happen based on the based on the values that are basically if you are using the merging the two data frames using a similar logic. So possibly you can merge the two data frames by using, let's say, the A column. So possibly if I am saying A, possibly the B will be B1 and the C will be C1. And if I am using a B, the B will be B2 and I don't have any. So possibly in a basic merge, this column would not be considered as such. This row would not be considered. So if this is C, then it is a B3 and it is a C2 here. And if it is a D here, then it is a B5 and it's a C3 here. So, and even a D contains a B5 and a C5 also here. So this is what will go as a part of the merging. So you are just pulling out all the common things from two data frames. That is what we are calling as merging. Whereas in case of join, right, the indexes are completely different from the two data frames, and you are trying to merge them into a single data frame. Possibly you may do something called inner join, outer join, left join, right join, etc. So this examples can really help you. So if I say I'm creating a data frame with 4 columns A, B, C, D, these are the 4 values, and I am giving the indexes as 0, 1, 2, 3. And let's say another data frame A, B, C, D, again the same columns. Column names are the same here. Here also the column names are A, B, C, D. Here also the column names are A, B, C, D. But the values are different and the indexes are also different. And similarly, the third data frame, again A, B, C, E. I'm changing the E here. The indexes are 8 to 11. Now, if I'm printing the DF1, obviously it is A0 to D3. And I can concatenate the 3. Now, when I'm using concatenate, what is happening? Simply getting attached. Simply getting attached. So I have, you see here, when you are doing the concatenating DF1, DF2, DF3. So overall, we have 5 columns, A, B, C, D, E. These are the 5 columns. The column names are the same. So overall, we have 5 columns. Now, in each of the cases, A0, A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, A11. So in because A is there in all of them, it's a row-wise concatenation that we are doing. Similarly, for B, you will get these for a, so basically the default is axis is equal to 0, which means it's a row-wise concatenation. But if you set axis equal to 1, then it would be a column-wise concatenation that would be done. Then similarly for B, for C, for A, B, C, you have the values, so it's going to be something like that. Then D, in the third one, the D is not existing. It's a E as a column. So that's where it would be NaN, not a number. Whereas in case of E, the first 8 values would be like a not a number, right? And similarly, if I say axis equal to 1, the axis is going to happen column wise. So you can actually try out with these things. So there is a join. As I said, there is a left join. I think we will discuss these joins and things in our next class, right? Because we will have to take some small example and we will take it on. Possibly I'll share this sheet. You can look at these things, but we will try to spend some time in terms of joining, because these are some of the things where you can really aggregate across the various data frames and combine, merge the data frames as well. All right. So I think I'll take a break here. We will continue this and we will move on to matplotlib and data visualization in our next class, which is tomorrow itself. Thanks a lot, everyone. I'll possibly address your queries separately. We will again catch up tomorrow's session. Thank you. Thank you a lot.